So for the construct understanding question, they give you a bunch of different graphs and ask you to kind of play around with them a bit. Now I've included the answer key for the construct understanding in your materials because there's quite a bit of detail that they go into. I'm going to kind of give you the highlights on here. The first graph that we're looking at is y equals a times square root of x. So my base graph is going to be y equals the square root of x, and in this case I've got a point at 4 equals the square root of 16. Now, the first thing they want you to do is, well, I guess it doesn't matter what order, but what if you wrote y equals 2 times the square root of x? So for 16, that would be 2 times the square root of x. I'll just write square root 16 is what we're looking at here. So 2 times the square root of 16 is 4, which would give me 8. So that means that my new point is going to be at 16 and 8. So I go up from 16 and I make a new point here at 8. Now if I had used 4, then I would be writing 2 times the square root of 4. And the square root of 4 is obviously 2, so 2 times 2 is 4. So this point was at 16 and 8. This point is going to be at 4 and 4. So I'm going to go to 4 and then up to 4 and write it there, which means that my new line, I can just connect these points now in the same sort of shape, goes like that. So this one would be y equals 2 root x. So you can see that the numbers have actually doubled from 4 to 8 here and from 2 to 4 here. So what we did was stretch the graph up a factor of 2. Now, the other thing they want to look at is what happens if I'm using a decimal. So I'm going to do y equals 0.5 root x. So again, if my point is 16, the square root of 16 is 4. So 0.5 times the square root of 16 is going to give me 4 times 0.5, which is 2, which gives me a new point at 4 and 2. So here I have 4. Oh my goodness. I'm just going to leave that giant pause in there. Sorry about that. But I kind of got ahead of myself there. 16 was my x. So the square root of 16 is 4 times 0.5 is 2. But just remembering that originally my point was 16. So at 16, I'm going to plot 2, and there I go. So I could probably try using 4 as well. So I'm going to go 0.5 times the square root of 4. Square root of 4 is 2 times 0.5 is 1. So that means that I have a new point at, I just about did it again, 4 and 1. So I can go 4 and 1. Here's my point. Make my new line under the curve. That should have kind of gone straight. So what I can see is that the graph, when I multiply it by a decimal, actually shrinks down from here to here. So shrinks by a factor of a half. This is what happens when you have a constant outside the function. You're affecting y. So it's kind of the same thing that we looked at before when we were doing translations and negatives. If it's outside the function, it affects y. So y, the y coordinate, when the x stayed the same, the y coordinate changed by a factor of 2 and by a factor of a half. Now over to the next graph, they start us out with y equals square root x again. And we're just going to focus on this point this time because it's a little easier to do the math and keep it on the screen. So we're looking at the square root of 4 is 2. Now, what they want us to do with this one is it's the format of y equals the square root b times x. So now we're changing something within the function. It's applying to x. So that's going to change the x value essentially. So what we want to look at here is if I have y equals the square root of 2x, what I'm looking at is if y were to stay the same, if y were to continue to be 2, then 2x would have to equal 4. So x would have to equal 2. So if 2 equals the square root of 2x, then x is going to have to equal 2. So my new point then is going to be at 2 and 2. So I'm going to graph that in at 2 and 2 right there. So then I can assume that my graph is going to take a shape that's going to be a little bit steeper because that point just shifted to here. But we can check that out by throwing in another point. Let's see here. How about we try 8? So I'm just going to put in an extra point. Y equals the square root of 2x. So I'm going to go, what would y be if it was the square root of 2 times 8? Well, 2 times 8 is 16, so y is going to be 4. 4 equals the square root of 2 times 8, because that's 16. So that means my points here, hopefully you can see it on your screen, is 8 and 4. So I'm going to go over here to 8 and up to 4 and put my dot in, which shows me that my curve is actually going to go like that. So this curve is y equals the square root of 2x. You can see that it kind of looks similar, but what's happening now is if I kept my y value the same, then my x value would be changing. It would actually be cut in half from what it was before. So that's a little different. My next point that they're going to ask me to do is they want us to do this y equals the square root of 0.5x. So keeping y at 2, just so we have that reference, and applying a value to x. Let's see, what's a good point to pick to make this clear? We'll go with well, let's just solve it algebraically. That's the best way to do it. So 2 has to be the square root of 0.5 times something, which means that 0.5x has to equal 4. Well, half of what number is 4? X has to be 8, which means that we're going to have a point of 8 and 2 on the next line. So 8 and 2. So we can see that this one is just going to be underneath the curve. And we've got our, we've got our 8 there, our 4 there, and our 2 there. So you can see that the pattern, well, if you did this on your graphing calculator, you'd have a really nice consistent spacing and pattern here, but you can see the general idea with what I'm doing. If I have a number under or inside the function multiplied by the x, then what's going to end up happening to the values is if y stays the same, x gets cut in half. So the relationship here is an inverse relationship where we're going to take this number and we're going to be basically going x divided by b. Or you could look at it as 1 over b times x to get our new values.